All right, so I think we can go ahead and get started. The two green lights are on. So we're going to resume now talking about design process. And I'm going to show you pictorially how I think about the design process. And I will use this process over today and tomorrow and use the same terms over the next 2 days. So the design process, I think, should start with what are you trying to solve? What problem are you trying to solve? What need are you trying to address? And describing that happens in terms of design requirements. You may need a certain price, a certain weight, a certain speed, a certain power, right? These are all requirements you would want in a final solution, and it's important to list those out. The next is you have to think about how are you going to solve that initial what? So you have that list of requirements. You need to think now, how can you think of strategies to solve them? And I talked about strategies before, and we're going to talk some more about this, about how you can think of strategies ideally independent of physical embodiments. Think about power flow, energy flow, weight. You're going to see some more examples of this, but there's ways to do this where you don't have to think about a certain device yet. You can think strategically about different directions of how you accomplish that initial what in your design requirements. So once you define a strategy, let's say we're going to have a hybrid electric vehicle, right? We figured out the energetics of the car. We think the hybrid electric is the best solution. That now creates a new set of what's. We need to make a hybrid electric vehicle. That is what we need to make. And now we need to consider, how do we do it? And so that next how is the concepts. And I showed you that in the Porsche example. We can think of the actual physical embodiment that can address the strategy, right? Now, I'm showing these blocks like this because in each of these stages, you want to generate multiple solutions. You never want to look at a singular strategy because it may not be the best one. You want to force yourself to think, could I do diesel electric, diesel pneumatic, different ideas of strategies, and then be analytical, evaluate what could be best, pick that, and then from that one, you're going to think of multiple concepts that can satisfy it. So the idea here is more ideas is better ideas, just like picking up the dog poop example, right? More ideas is better ideas. You want to do that in every stage, evaluate what the best concept is, then you're going to define modules, just like the Wright brothers did. They had lift, control, propulsion, and when you think of all the modules that are in the concept you want to build, you're probably going to find one that's the most critical. That's why I have MCM, most critical module. And this I would focus on first. If this is not successful, it may kill the whole project. In the Wright brothers case, it was the wing shape. Literally it could kill them if it was wrong. So they had to focus on that first, and then they added in control and power, and that would be the other modules here. So you build out your modules, and in each of these modules, you generate more ideas. You want multiple ideas, and you evaluate which is the best one. And we'll give some more examples about how to evaluate that. Sometimes it's a mathematical equation. Sometimes you have to do bench level testing. Sometimes you do more qualitative metrics, but you want to be confident you're picking the best solution. Then what you do is you build back together all those different parts of the problem, just like the Wright brothers did, into the final solution, the final prototype, the final product. So some notes about this that I think are important is thinking about how important it is to define your design requirements correctly from the beginning. And I think about this in terms of a design trajectory. Like if you are incorrect in your requirements, if you have bad requirements from the start, it's going to put you on a bad trajectory, and over time, as you do more and more and more and more and more design, it's just going to get worse and worse and worse and worse and worse. And in the example I gave of that is like the life straw. Great idea, no doubt, but I don't think they had all the requirements set from the beginning. So instead, what I encourage you to do is take the time to put yourself on a good trajectory by investing in understanding your requirements. This goes back to your question during lunch of if you just have an idea and you want to prototype it, you could be on that, you could set yourself on a bad trajectory because you haven't gotten the rest of the requirements. So really try to force yourself to get as many of the requirements as possible. But the other thing to do is iterate. At each step, look back. You know, when you generate some strategies and concepts, look back and say, am I going in the right path? Can I make a better and better design? Because I'm reflecting on the decisions I've made. And then, you know, in this whole process, you'll often get to the end, like making a prototype. Prototype's not a product. And you may circle back and do this process again. Iteration is powerful, right? You want to learn from your mistakes. Okay, so now we're going to switch it up and start talking about user-centered design and really trying to meet the needs of people. And that's going to drive a lot of the discussion over the next part of the lecture. And I'm using this picture again because I think this is it happening in action. I have multiple users in this picture. I have the maker of the irrigation equipment, the actual user of it in the field. I'm also a user in that I'm trying to derive research out of this project, right? And so we have to think about the needs of all these people. Okay, so to start out, this is a book that I highly recommend in talking about ethnographic research. And what ethnographic research is it's the study of people and how they behave. And as a product designer, you use ethnographic research to get insights on how a person may use a product, how they may desire it, how they may pay for it, etc. And so this guy, Jan Chipchase, was he really became famous from his involvement in the early Nokia cell phone designs. The Nokia 1100, do you remember that model? It was very popular here in India. The one with the flashlight on the top. He was pretty instrumental in that. And that phone is a brilliant design because it has a lot of features that address latent needs like we were talking about. So, you know, one of the latent needs was that sometimes people need to get around in the dark, right? And they have this thing in their hand that has energy in it, and it could have a light on it. Why not put a flashlight on it? It has, those phones had to be low cost, they had to have long battery life, and so he was able to assess the market differences in a place like India, or they were also very popular in Africa, versus the much more expensive products that were on sale at the time in the US and Europe. And Nokia sold, you know, millions and millions and millions, hundreds of millions of those because of that really good ethnographic research. But I'm going to give you just a short summary of the important points that I think are really valuable from this book in doing ethnographic research, studying the behavior of people and understanding how they'd use products. So the first idea he talks about in this book is this thing called threshold maps. And what he means by that is the threshold at which a person makes a decision to do something in their life. So, for example, at what point do you have to get dirty and sweaty enough to take a shower, right? A thing, what this picture's showing in this store is when people go grocery shopping, maybe they're kind of hungry, and what the store does is put free samples of food out for people to try right next to where it's sold. And so they're kind of hungry, they're tired, they're like, ooh, I want to eat this food, because their threshold is low. They're kind of hungry, they want to eat. And then that makes them more likely to buy the products. So if you can go and observe people operating in their day-to-day life and see those points when they make a decision, you can use that to your advantage to have them make a decision to buy your product, to appeal to them at those points. They're appealing to people's hunger and their desire to get free stuff in these conditions, right? And they're appealing to it, and then you're lowering the barrier to buy it because people are like, this was tasty. I like it. I'm going to buy it right now. The next point he talks about is tying into the status of products. Like how do people perceive the products and how they reflect on their lives and how it demonstrates them, or how it projects them to the rest of the world and how people perceive them. And you see companies leverage this all the time. Like, I loved Apple's ad campaign when they came out with the iPod, because what they did so brilliantly is they made white headphone wires instead of black, right? And so when you saw a person walking around on the street, this was like mid-2000s, when you saw a person walking around the street with white headphones, you knew they had an Apple product. It was a status. It was a nice high-end product. And they had a whole ad campaign where people were dancing around in silhouette, so their bodies were blacked out, but you could still see the white headphone cable. So it really highlighted that identifier that the people were using Apple products. I think engagement rings and how they're used in the U.S. and Europe, and also here, people wear diamond engagement rings. It's an expression of wealth. It's an expression of, I have a partner in my life. You know, it's really a wedding ring the same way. This is telling everybody around me, I have a certain condition in my life, right? It's a status that you are married. You know, designer handbags are one. Like women will buy, but like Kate Spade is the company of handbags, and that's saying, hey, I have good taste. Hey, I'm wealthy, you know, by the handbag I wear. I use this too. Having an MIT business card helps getting into companies, right? Because of the status of this school. I'm being totally honest about this. If I email or call up a company and say, I'm a professor at MIT, that helps me get in there. You guys can do the same thing. Same thing with IIT. You're in a good, privileged position to do that. The next one is being aware of how a product diffuses into the market, where you have to understand that people will start learning and finding out about a product, and they'll start being aware of it. They'll gain interest. They may go into a store and play with it and test it a little bit. They'll try it, and then it will move into adoption in large scale continued use. So like understanding that flow of how a product will grow is important. And also who will start adopting it and when. And so these are different portions of the population that will adopt at different times. So the innovators and early adopters are the ones that are willing to take a risk. Maybe they buy every new iPhone that comes out immediately when it comes out. They love new technology. They're willing to test it. Then you'll get the bulk of the population adopting a bit later. And then you have the laggards or non-adopters. These might be like your grandparents who still don't know how to type an email, and are really not tech savvy. And these are people maybe like our US politicians who are like, oh no, I can't send an email ever. It's just, I only deal with paperwork. So, you need to think about like how these different people behave and how they adopt products. So a big part of this book is giving good advice on how to go do ethnographic work. And me and my team do this a lot of times, and I've summarized it here. But he talks about calibrating your cultural compass. And this is all about going out and observing people operating in their daily lives and observing how they make decisions. So one thing he says is wake up early, like before people start their days, so you can be out on the street and see people as they come out and start their daily routines. Ride local, ride on buses and ride on public transport. Watch how people travel. Watch like how they spend their time on the train, how they pay for different things. It's really all about observation. Visit social hubs, like where people tend to congregate. Maybe it's a tea shop here. He talks about breaching cultural norms. I'm trying to think of a good cultural norm here. So yeah, I'll give you an example. So in America, if I'm like in a customer service type situation, like I'm dealing with somebody, and they do something I don't like, maybe I'll get mad at them. I'll like yell at them. I wouldn't do this, but like maybe an American would, and maybe in India you would not. And sometimes you can intentionally break a cultural norm. Okay, here, I'll give you an example here. What if you just started talking to your professor and calling them by their first name? Just be like, hey, Sudipto, what's up? Right? Right? That's really funny because you'd never do it. But it's breaking a cultural norm, and you can see what happens. And what it's doing, if you want to put it in like a dynamics type analogy, it's adding a perturbation to the system. And you're seeing if the system like devolves into chaos or it corrects in a different way. And so you're just making a choice to do something different than people usually would and seeing how they'd react, you know? And so you can test those waters, and it may be somewhat offensive, but you know, in that case it's not. You're not hurting anybody, but you'd see, you know, how's it different, and maybe you could do something to design around that. He talks about visiting international chains. Like it's fascinating for me to go to like KFC or McDonald's here. They're totally different than they are in the US. Like so many different menu items. I think like chicken McNuggets and Coca-Cola are like the only two things that are the same. But it's really interesting to see like, you know, things like the chicken Maharaja Mac, right? We don't have that in the US. That's like, it's cool that they said Maharaja, right? So they're appealing to something like, you know, old royalty here. And they're tying into the Big Mac in the US, which is a beef-based burger, which they never sell here. But it's cool to see how chains are adapting to specific cultural desires. And I think McDonald's and KFC does that. Like the peri peri spice in the fries, that's really cool. I had never seen that before, and I noticed that while I've been here. We don't have that in the US, but the like shake bag, and I've been observing that people use it a lot. Do you guys like that? Have you had it? The spice that you shake the fries in? Yeah? Is it good? Yeah. Okay. Well, that's interesting. Reading signs, like literally, like road signs and advertisements can be powerful. Understanding the dynamics of the community and capturing that spirit. And I think, you know, for us in my group, it's really important to balance qualitative with quantitative. That like we're doing these qualitative observations of how people behave, but let's say a farmer is pushing a wheelbarrow, you know, on a farm, we might do an energy calculation to understand how much energy they use, how much power they use, to think about could a power device be useful in that context. Another important point of this book is trying to distill the essence of a product. And what that essence is really the core functionality and value you get out of a product or solution. So in these pictures, both of these are gas stations or petrol stations, right? These are jerry cans full of petrol. This pumps petrol. This also has a convenience store. You can buy food, you can buy supplies, you can buy all these things, but at the essence, they're a place to get petrol, right? And so if you can boil that down and see what that essence is, you can see like what the core value is and maybe modify some here and there. Actually, one of our partners, Tata Projects, is doing that, where they're working with Hindustan Petroleum Stations, and the essence there is certainly buying fuel, but they're realizing, wow, we have a lot of people coming in and buying fuel. They're spending some time there. We could also sell them clean water and other supplies. So they're creating these little stores that they're putting at HP stations, which is really interesting. So one thing to be careful of, though, is once you define the core essence, be careful of adding creeping featureism. It's like, you know, when you buy a cell phone that does so many additional features that you'd never use, at its core, a cell phone now is probably a phone and an internet point, you know, source. So maybe you don't need all the crazy bells and whistles and features. Try to use fresh eyes. Try to look at situations like you've never ever seen them before, and try to put yourself in the perspective of like a brand new user. That can be powerful. Inject crazy ideas into brainstorming. Like I was talking about, buy a cat instead of a dog to avoid dog poop, right? That's a crazy idea, but it may make you think in a different line. And then, yeah, strip down a product to its essence, and then you can build in features and try to assess value. Another important book that I use in my class, I didn't tell you this at the beginning, this short course that I'm teaching now is kind of a condensed version of a semester-long course I teach at MIT. And the Hidden in Plain Sight and then Poor Economics are two books that I use. And the reason I'm bringing up these books is that they're not necessarily engineering books, but they're giving you insights on problems and how to design from different perspectives that can be really powerful to us as engineers. And this book is all about how poor people make economic decisions and how they live their life economically. And I think it's also important to stress that I think what makes a powerful and great designer is being able to see a problem from as many perspectives as possible. I tend to see problems from an engineering perspective. That's kind of my natural background. But if you can see it from like a user's perspective, a manufacturer's perspective, a corrupt government official's perspective who wants a bribe, not kidding, and like all these different perspectives, you're going to get so many insights that you can use to design your solution. Because you may have to appeal to their needs, right? So don't be locked in from your own perspective, like that guy sitting in the cubicle in his little office. Really try to broaden your perspective. And the reason I use these books is because I think for a product designer, it's really powerful to see how people allocate their resources and think about how do we appeal to their wants and their needs at the same time. So some examples of this, we talked about it a little earlier. I showed this picture, is what people value or pleasure and how they may allocate resources to it. And there's a great quote in this book where they're talking to this really poor person who's actually malnourished. They're not eating quality calories, quality food, or enough food, but they have a television. And they're like, why are you buying a television if you're not even buying food? And his quote is, TV's more important than food. Because TV is what's entertaining him every day. He really, really values that. Alcohol, tobacco, like people value that and allocate a lot of resources to it. So like understanding that psychology is I think, really, really important. Another one is when you're talking about subsidies, they affect different stakeholders in different ways. The authors of this book are quite famous for showing why the government of Kenya should invest in deworming medication for children so they get sick less, because they were able to model that as these kids get sick less, they go to school more, they end up going to higher grades of school, they end up making more money because they get better jobs, and they end up paying more taxes. So the country actually makes money in the long term, in like the 20-year perspective, off investing in this relatively low-cost medication because it helps their whole economy. So that subsidy is affecting things at a government level. At an individual family level, maybe you can incentivize people to come get like vaccinations by giving them free stuff. Free pots and pans, free food. You guys are all students, so you'll probably come to an event if there's free food, right? That'll make you more inclined to come to an event. That's kind of a subsidy. Another idea is, if as a designer you can give a person a good solution by default, it can be very valuable and helpful for them. Instead of having to make a choice or appeal to a desire, if you can couple a need with a desire, that can be really valuable. So some examples of this is there's a company in India actually called Gram Vikas that does water purification systems. And what they do is they go into a village and they install both water and sanitation in every single household. And they don't turn it on until every household's ready to go. And then they supply clean water, so people by default, when they're getting water, it is clean. And so they're getting that health benefit by default. They don't have to choose to go get clean water. They just get it. That's all they get. Another example is like iron fortified flour. You can buy flour that already has iron that helps with anemia, or iodine treated salt, right? People want the salt, they like salt, but they can also get that benefit of iodine. Another example they talk about is how families allocate their resources as far as status. And so one they talk about is investing in the smart child, or pushing people towards secure jobs like being in the government, or being a doctor or an engineer, or choosing aspirational products that look good on them. But this idea of investing in the smart child, I use this picture. This picture works better in the US than here. These two are very famous American football players. They've both won multiple Super Bowls, and they have this brother that nobody's ever heard of. And like nobody even knows this guy exists. And like these guys are pushed so much in the media. And it's not that the parents were unloving to this guy, but it's like more resources have been put towards these two people, certainly by society, and more spotlight on them because they're the high achieving ones. They're the great athletes, you know. So this is Peyton Manning. And this is Eli Manning. Yeah. You know them, right? Yeah. Peyton's now retired, but Eli still plays. So anyway, it's important to understand those dynamics of a family. Like how are they allocating resources? What are they pushing, you know, to spend their money on? And who are they investing in a family is also part of their allocation of resources dynamics. Another one is they talk about supply versus demand-driven solutions, and they give this great example of contraceptives. Over the last decades, there's been many like health organizations that have gone into communities in poor places around the world that have given away condoms and say use condoms. It prevents HIV transmission and unwanted pregnancies. And in Latin America, there was a lot of push for this in places like Brazil. And people weren't adopting them. There were still large families. Women were having more kids than they wanted at younger times than they wanted. And what happened is that the soap operas, the television shows about like dramas between families and stuff, they would depict women who would have none or maybe one child. They're very beautiful. They're maybe in their 30s and they still haven't had children. And what happened is it created an aspirational condition where other women wanted to be like them. And so because of that, they started choosing contraceptives and lowering family sizes. So in this book, they were actually able to track that dynamic, that what actually made a big difference in family planning in Brazil was television shows, not health organizations trying to give away contraceptives. So this is another example of like figuring out what do people aspire to, what do they like, who do they look up to. You guys, this happens here all the time. Look at how Bollywood actors are used in advertisements, right? And look at how there's a lot of, I think, sensitive racial aspects to that too. Look at how they look and their skin tone and their level of wealth and where they live. And I think as an outsider, it's fascinating to watch commercials in this country.
All commercials are meant to give you inferiority complex.
Yeah, exactly. Exactly. Yeah, you want to achieve to that. You want to aspire to that. So as designers, use that to your advantage. And certainly the designers of products here are doing that. So here's another concept of just thinking about how many stakeholders are behind a problem and behind a solution you want to design. And it goes back to this idea that you don't want to just design for a single user, like the end user. You want to design ideally to meet the needs of the entire ecosystem. So this is a paper, it's called Customer Value Chain Analysis, that was written a few years ago, actually 12 years ago, 13 years ago. And it was about a small irrigation pump in Africa. And so they were looking at this NGO, this non-governmental organization that would ideally make and sell this. And they had to think about the flow of money, the flow of how people care about the product, like numbers of products, et cetera, and all these different stakeholders that are involved in the decision and the dissemination of this product.
You're going to give me a differential equation for the heart also?
The heart? No. If you had come to class on time, you would have heard me talking about this. Here's me being disrespectful to one of your professors. I was telling them, we were talking about breaking cultural norms, and I was saying they should just call you, hey, Sudipto, what's going on? You know? But no, I was saying that sometimes you can put a differential equation on these actually if it's like process flow, but sometimes you can. You have to observe how people make decisions and what they care about. And so what's I think interesting about this paper is they did map out this rather complex ecosystem of all the different stakeholders that affect getting a product to the farmer. Here's the end user, right? And look at all these different organizations that are involved. Here's the corrupt government official. Look, money's flowing to them, and it's questionable, are they actually interacting with all these people? But you got to flow money to them. You know, there's local manufacturers, distributors, et cetera. So it's a really complicated dynamic, and my group certainly spends a lot of time mapping this out, and not only mapping it out, but trying to partner with all these organizations, like get their insights because they're partners on the project.
That's dangerous. So do you have any book on that? That dollar going to the
I'm trying to think. We certainly don't make a practice of bribing. I can't think of when we've ever paid bribes, but there's been difficult customs situations sometimes. We certainly have to try to understand subsidies, and we certainly work with organizations that are in a position to influence subsidies. I don't think in a corrupt way, but they have like lobbying groups, in the government. But I think being aware of that dynamic here is important. I think less so in this country, but there's other countries where it may be more and more important. Okay, so the next point is thinking, as you're thinking about this wide network of stakeholders, you want to think about who are the subject matter experts you can engage. And I showed these pictures earlier because these were subject matter experts that we could identify would know about the problem and know more than we would. So I talked about this guy knows about prosthetic limbs because he uses one. This guy knows about farming because he's a farmer. And these are pieces of knowledge that we wouldn't necessarily know ourselves. And an important point here is just creating the dynamic and the rapport with these stakeholders in that you're designing with them and not for them. If I can come in and start interacting with a guy like this and say, I really value you being here and working with us. I really value the knowledge you're bringing to this problem. And I recognize that if you and I are combining our knowledge, we can produce something better than either of us could have done alone. People respond really powerfully to that. And a lot of times in poor communities that we work with, they're accustomed to NGOs coming in and just giving them things and having this like, I'm higher than you, so I will provide to you type dynamic. And if you can come in instead and say, look, we're equal. And this country has the caste history, right? You guys are at a very high, social level being at a school like this. So if you come into a village, I would be, if I were you, I'd be very conscious about what image are you projecting and how do you build that rapport with those people that you need information from, right? You don't know their information necessarily, and they have valuable information to provide to you. And you can build that rapport very actively. So I also, as well as people, I also think about what organizations can we work with who are subject matter experts that would know knowledge that we wouldn't have. So I work with a number of companies throughout India and globally, but GIAN and Mahindra and Tata are examples. This is International Development Enterprises. We've worked with them in the past. But the reason we work with them is they typically have market knowledge that we wouldn't. I'm coming into a problem thinking about technology. I don't have a marketing background. These companies make and sell products. They usually know what's going on. They're able to distribute. They think about economic viability. They think about price points. You're going to see an example of that in a second. That was really important that we figure out because of input from these companies. So, talk to them. And key questions that I'm always thinking about as I'm engaging them is I'm trying to think about going back to that Venn diagram of value propositions and merits. And I talked about that value merit. I'll ask them, what is a new opportunity for your business that you foresee? What's a new market you want to penetrate? What's a bigger market percentage, market share that you want to get? Are there new consumers that you'd like to engage that you're not engaging? And I try to understand, what are these opportunities that these companies want to go after but are not able to yet? And I work with them to understand, is it a technical barrier? What's the governing physics behind it? Could we make an impact? And if it comes down to that, yes, it is a technical problem, it does require rigorous engineering and research, maybe I can help. But I have to go through this discussion and this kind of courtship to understand what are their needs, what are their desires, how could we help, and then I can make a value proposition to them. Maybe our research could help them get over a hurdle to engage these new markets and make money. So a big part of this is listening. And that's a lot of what I have to do when I go talk to these companies. A classic mistake I see of so many of my colleagues is companies come to MIT all the time, every single day. There's companies who want to meet with professors. And the company will come into our office, and I see my colleagues so much of the time say, here's what I do for research, here's how I think it could work in your company. And so I'm just pushing what I have on them. And I try really hard to step back and first say, what do you need? Where do you see your business going in the future? What opportunities do you need? Why can't you get there? And we have a conversation. And I talk about what my group does too, and maybe how it could interact with their company and be valuable to them. But I really try to understand, what do they need? And that's something I encourage you to do. Don't just push your ideas on. Listen, try to absorb information and analyze and process. So to give you an example of this, I want to tell you about how we started interacting with GIAN Irrigation. Do you guys know this company? Yeah. It's the second largest drip irrigation company in the world. It's based in, I was there yesterday. It's based in Jalgaon in Maharashtra. And their core business is selling drip irrigation equipment. And about 6 or 7 years ago, I started interacting with them. And I went there multiple times actually, and started talking with them. What do they see as new opportunities in their business? And I thought about the whole hierarchy within the company, not just the executives, but all the way down the hierarchy down to their customers. And what came out of those conversations is, you talk to the company, you talk to the executives, and obviously they want to expand their business. They want to expand drip irrigation. And so then I had to ask, well, where do you see areas for further expansion? And they said, you know, the market that we really can't tap into easily right now is off-grid markets, particularly with small-scale farmers. And then I had to ask, why? Why is that? Why are there barriers? So I had to talk to other people in the company and understand the agronomy of using the drip system and how it moves water and how the plants respond and how farmers make money. I had to understand like what the equipment costs, what determines the flow of water, the power through the system, you know, what's going on in these systems from like a technical perspective. I had to understand what are cost drivers and technical aspects in the production of drip systems. This, by the way, I didn't say this before, this is what a drip emitter looks like. This is what drips water out onto the crops. That's why this picture is here. But anyway, I had to understand like what drives their cost is material cost a lot of times, and they really like using low-density polyethylene because it's really cheap. But in a lot of these drippers, they have to use silicone, which is, you know, by volume much more expensive and a big cost driver for them. And then I had to understand like how do they distribute products? How do they interact with farmers? What fails, etc. And what came out of all of this entire hierarchy, was the core design requirements of a system that could potentially be disruptive and enable them to get into off-grid markets. And so the big thing that came out of this is that the reason off-grid markets can't buy drip irrigation is because of the cost. What drives the cost is the pumping power required to move water through the system, because you need to buy the pump and you also need to buy the solar system to drive it. What drives that power is the pressure required to move water through the system, right? Power is pressure times flow rate. Flow rate, the plants need a certain amount of water per day, so pressure is what we could reduce. And so that made us realize that if we could go from, typically these run at about 1 bar or 1 atmosphere of pressure, if we could cut that by about 10 times, we could cut the capital cost of the system in about half. Massive, massive sensitivity to overall costs. And we had to model the physics behind this. We also had to understand that they had to be pressure regulating or pressure compensating, meaning they deliver a constant flow rate with variations in pressure. We understood the price point of what they had to cost, and we wanted to make them clog resistant. This happened over a number of visits. It's not like I can waltz into a room and know this in 5 minutes. It takes time. And so we also did the bench level or back the envelope calculations to understand how much power would we need and would solar be viable at those low power levels. And then what was really interesting that happened, and this goes back to the iterative nature of design, is that when we were first thinking about how we would design one of these drip systems and make it as cheap as possible, we studied how GIAN makes 2 different styles of piping. One pipe, which is a thick wall pipe, and one that's a thin wall flexible pipe. And the thin wall one has less material per length, so it's cheaper. for material costs. So we said, obviously, we'd want to use the thin-walled pipe to lower our cost. And Jane came back and said, no, 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 no. You have to use the thick-walled pipe because the Indian government only subsidizes the thick-walled pipe, not the thin-walled. So even though it's more expensive to manufacture, it's less cost to the farmer to use the more expensive pipe. I would have never known that. I'm a guy from Boston who doesn't know Indian government subsidy structures. Jane does, and they were able to tell us that. But also we learned from the bottom of the hierarchy that farmers prefer the thick-walled pipe because when a bullock steps on it, it doesn't rupture. It's more rugged. And so these are different requirements that drove this that I would have never known. I wouldn't have known from the physics. I probably wouldn't have known from the middle of this hierarchy, but we were able to assess it from the top and bottom. So again, what's so important here is listen. Listen to all the people that have influence on whether your design is going to be successful. But I'm going to put a caveat on that. Do not take information from stakeholders as the word of God necessarily. They are wrong sometimes. In the balancing act we have to do all the time is push back. We have to question assumptions. So for example, with Jane, many times, we've said, we think we can use a lower amount of pumping power and we could use a smaller pump of this power level. And they'll say, that pump is not available off the shelf. We cannot buy it. And we have to say, but it could be made by somebody. It's physically possible. And so there's that back and forth dialogue of like questioning assumptions and trying to come to truth and actual insight on what would be viable. Another area where I see this all the time is companies will come to me and say, we want a product that does X functionality. Let's say, I'll give you an example. I work with a company that does harvesting of a crop. I won't tell you the details of this, but they do harvesting of a crop, and they say, we want tools for our harvesters to cut this crop faster so we can reduce labor costs and save money. And what I have to hear from that is they want to save money, right? Cutting the crop faster is one way they could do it. Hauling the crop faster is another way. Reducing wastage is another way. Right? So I'm listening to that latent need that they want to reduce money, right? Reduce costs. And it's up to me as the designer to look at many ways to do that. And actually in that engagement with that company, I've had to push back a lot to say, look, and use the analysis to say, no, you should not change your habits of the cutting, the people doing the harvesting, because they're the most efficient. You should change habits of the haulage because you can move product faster and save money that way. And actually, we're designing stuff around that idea. So that was an example of pushing back on assumptions. Okay, so now I want to talk about actually generating design requirements, strategies, and concepts. And so we're going back to these words I used earlier in the presentation. I'm going to use this example of, this is a solar-powered water desalination system, which is, this technology is a big part of what my research group does. So, and we're going back to this design process, and what we're going to talk about in these next steps is, in the design requirements and strategy, we're talking about a plan of action in the strategy, ideally independent of physical embodiments. And in the concepts, that is the part where we start getting into physical embodiments of that plan of action. So anyway, about 6 years ago, my groups started working on water purification in India. And we had to figure out a strategy for what we were going to do. And so this was an important part in the evolution of this project because I see all the time academic groups hear about opportunities like we did. We need, you guys all know clean water is an issue throughout India. And people hear about these opportunities and say, I'm going to design a water filter, or I'm going to design an RO system. And they launch into a solution path without necessarily fully understanding the problem. And so a critical point in this project was us taking a big step back, which turned out to be a 2-year step back, just to study the market and study the requirements to understand what direction should we move in our technology development. So the first thing we tried to understand is what is going on with clean water in India? What actually makes the water dirty? And the most prevalent contaminant of water in this country is salt, actually. This is a map of showing the salt level in water, the TDS, total dissolved salts, throughout the country. And everywhere where you see a color other than blue, the salt content is higher than the WHO recommended healthy level of what you should drink, and you can taste it. It's higher than the taste threshold. So 60% of the land area of this country has water that is really too salty to safely drink. 70% of the population gets their water from groundwater, though, right? And most people, particularly people in poor rural areas, are having to drink this stuff. Now, what exacerbates this problem, too, is that India is really water stressed. And so if you're taking water out of the ground, taking salt out of it, and not utilizing it effectively, you're wasting a potentially precious resource, particularly in the northwest of the country. So this is a difficult challenge. You have water stress and you have salty water. But what we also understood is that if, say, you're looking at rural communities, and I'll talk a bit more about that in a second, but if you're looking at rural communities, and still in this country, the majority of small-scale villages are going to have intermittent or no grid access. You have to think about how could you power a system to get this salt out of the water. And it turns out that there's kind of a natural synergy between where the water is saltiest and where you actually have the most solar irradiance. So this is how much sun power you have available if you were to do a solar power system. So my point here is that we started investigating the ecosystem around the problem, and we started getting insights on aspects that we could use to our advantage. And we started putting together this kind of master Venn diagram of the problem. So as I said, you have brackish water, you have water stress, and users don't like drinking saline water. It tastes bad and it gives them bad health effects like kidney stones. So this made us understand that because salt is so prevalent, we needed to desalinate the water. And because India is so stressed, ideally we could best utilize the water in our recovery of the water we're taking out of the ground. So we're saying here, ideally we'd want a 90% recovery ratio, which would be like only 10% wastage. Recovery is how much product you have relative to the input water into the system. So this started making us understand kind of the socioeconomic, cultural usage factors of the problem. And then we had to understand the technical as well. So we had to do the research on your population statistics in the country, and it turns out that the median village size in this country is 2,000 to 5,000 people. That accounts for a quarter of the country's population. And per WHO standards, people need an average of 3 liters of drinking water per day per person. And so that set the requirement of if we were to make a desalination system in a village, how much water would it have to produce every day? So, for 2,000 people, it means 6,000 liters, up to 5,000 people, 15,000 liters. So, or meters cubed per day, 6 to 15 meters cubed per day. We know we have limited grid access in these rural areas. As I said before, most rural villages don't have reliable grid access. And because of the synergy with PV power or irradiance, we knew that PV power could be valuable. And then we had to understand what technologies could be viable in this space. And we looked at many, many different ways to get salt out of water. And the de facto solution would have been reverse osmosis. I bet most of you have an RO system in your house, right, in the kitchen. Yeah, it's very, very common, particularly in like middle class and above households here. And so the way that works is it's the opposite of the osmotic process, which would draw low salinity water into a high salinity solution. Instead, you can use an applied pressure and drive that water backwards. That's the reverse process to make the low salinity water. So that would have been the de facto solution, but we also, by understanding the technical space, understood that another technology could potentially be viable, which is called electrodialysis. And the way that works is using an electric potential to move salt out of the water. And the way an electrodialysis stack is set up, this is called a stack, is you have alternating membranes, anion or cation exchange membranes, that can pass ions of one charge or another. So the way this works is you feed saline water in between these membranes, you apply a voltage across a stack of membranes, the salt ions are pulled one way or the other, and at most they can travel only through one membrane and then they're blocked by the next opposite charged membrane. So you end up with alternating channels of your diluent, which is your product water that you can drink, and concentrated brine. So we worked out all the energetics and thermodynamics of these systems and really understood the technical side of this problem. And the big insight we had is that even though RO is the market leader, when you talk about salinities that are relatively low compared to seawater, so throughout India you'll find around 1,000 to 2,000 parts per million total dissolved salt. Seawater is 35,000 parts per million. Electrodialysis requires only about half the energy compared to reverse osmosis, specific energy, energy per volume of water. That makes a big energetic impact. Why that's so important is we also had to dig into the economics behind this space. We tied up with Tata Projects at this point. Tata Projects has done about 3,000 village scale RO systems around the country, and only on grid, because they've realized that photovoltaic powered RO systems are currently unviable because more than 50% of the total system cost comes from the power system. So they double their costs when they try to go off grid. It's just not viable and they can't sell it. And so why this energetic reduction is so valuable is we can cut the cost of that power system by more than 50% compared to if we were using reverse osmosis and make it cheaper. The other big advantage is going back to the water stress condition in India, is that most village scale RO systems waste about 60% of the water that come into them. Electrodialysis can run at much higher recoveries and waste less than 10% of the water. So all this put together, the moral of this story is we took the time, took actually 2 years to put together this whole detective case to see the disruptive opportunity of photovoltaic powered electrodialysis as a game changer potentially in this country. And that has gone on to attract a whole bunch of sponsors to do this project all over the world. And we've done a bunch of pilot systems at this point. And I'll tell you about that in a second. But the moral of the story here is we took the time to understand the problem. Going back to your question at lunch, what if I want to just go make something? We could have gone and made an RO system, but it would have been too expensive. We could have used many other technologies. It would have been too expensive. We literally took 2 years really just to get the design requirements. And it wasn't just observing the requirements, it was doing a lot of engineering analysis to derive the design requirements and be confident in them. So another point here that was important for us is realizing the chain of stakeholders that was going to be involved if we were going to make a solution a commercial reality. Take an idea and make it into a real solution. And I always try to think about this chain starts with end users. We're trying to meet the needs of people who need clean water. But as you create a technology, it's going to go through a number of phases. Going from first, you're going to innovate new ideas, you're going to validate them, then ideally you commercialize them, and you disseminate them. And it was really important, going back to this idea of recognizing your own ignorance, recognizing your own limitations, it was important for us to recognize at MIT, we were in a great position to do research, right? Do that innovation stage, right? Prototyping stage. We were not in a good position to make commercial products or even necessarily run field pilots to validate. So it was really important for us to team up with USAID, which is our agency for international development in the US, as well as UNICEF, which is a UN organization. They funded field pilots for us in different parts of the world so we could refine this technology. We had to team up with Suez, which is the market leader in making electrodialysis. And we had to team up with Tata Projects, which makes integrated desalination systems. And because of this, if you can link all these links of the chain of stakeholders, you'll have more confidence that you can go from an inception of an idea all the way to implementation in the real world. If you break any of those links, you might not get there. So we try to think about what is that chain of stakeholders and how do we get them on board. And all of these are on board as partners on this project. So we developed our relationship with USAID because we actually made our first system as part of a prize competition through them that we ended up winning. This is a 8 cubic meter per day system we made in New Mexico that led to field pilots in India, and now we've done more in India and Gaza, and actually on Thursday and Friday of this week we're kicking off another pilot outside of Hyderabad, a much more condensed, like small scale, little one, much lower cost. So anyway, the point here is that we did the homework, we did the detective work to understand what are the design requirements, but then we coupled with that making things, doing prototypes. Going back to your point again, we don't just do the analysis, we make the prototypes, we've tested them in the fields, and these field tests have shown us weaknesses in the technology, how to make it cheaper, better, more reliable, and we keep iterating in that same design process, as I've been talking about. Okay, so some points about summarizing, defining your design requirements and strategies. The first is you want to understand where your motivation comes from. And this is going back to the Venn diagram of like problem merit, right? Are there new markets you're trying to gauge? Are there tough situations you're trying to address? Can you look in the literature, what's going on? Why should you solve this problem? You want to answer that for yourself. Then you want to understand who the stakeholder network is, or stakeholder chain, and do the customer value chain analysis and understand whose requirements would you want to meet or have to meet to create a viable solution. You want to think from a user-centered perspective. You want to do the ethnographic research we've been talking about. Go observe people. Go to their village. Try to live their lives. Try to put yourself in their shoes, right? Try to empathize with them. Map out how they might buy and use your product. Understand all of their needs and desires. This was important, by the way, for clean water in the desalination example. I'll joke a lot sometimes in presentations that anybody we meet on this project has always had clean enough water not to be dead. That's why we're meeting with them. And they've probably gotten it for free. So if they're not dead and they're meeting with us, how do we appeal to them to buy water, to buy clean water? And we had to understand things like people now understand that if they buy desalinated water, they're less likely to get kidney stones, which saves them a lot of money in the long run because they don't need surgeries. Also, they like the taste. We can appeal to their desires because drinking salty water sucks. It doesn't taste good. You need to think from a machine design perspective too, like what are the critical physics? What are the theoretical relationships that govern your problem? What, from an engineering perspective, would constitute a viable solution? This is how we chose electrodialysis over reverse osmosis. And be quantitative as much as possible in your design requirements. You know, say $10 instead of low cost. You know, say 75 decibels instead of quiet, right? Actually try to assess those factors that are important. All right, so this is perfect. This is a good stopping point. We're going to pick this up right after lunch, and we're going to go into some actual analysis of examples. Questions before we break for lunch? Are you still awake? Yes?
In the ethnographic research, you talked about vaccination in Kenya. That you told us that instead of if they were vaccinating some kids, they were providing with some candies or gifts or any other products. So, or in desalination example, just like you give, that you will talk about the taste of the water instead of like it is giving us the health benefits or something like this. So, like, is it like the main purpose of the whole research is that we just need to keep it into the daily activities of the people so that they don't need to do much effort and they don't need to worry about the long-term goals, like only the short-term instant gratification sort of thing?
I would frame it a little differently. What I would say is that the more ways you can appeal to a customer, the less risk you have in them adopting your product. So if you can appeal to a parent's desire to have their child healthy, that is a motivator for them to get a vaccination. If you can additionally give them some reward for doing that. Give them some food or something. That's an additional motivation. And I think good product design does that. Like we get a lot of utility from our cell phones, but they're also quite entertaining. They're appealing to us in many ways. So I would say, like, try to maximize the appeal in as many ways as possible. That's the way I'd say. I'd reframe what you said.
I have a question regarding the wheelchair that you have designed.
The ability of what?
The wheelchair which you
Yeah.
designed.
Yeah.
So before designing the product, you might have done some user study, right?
Yeah.
Extensive user study for knowing how actually it affects the life and the entire lifestyle.
Yep.
So when you show your design to them and asking them to adopt to it, what is the first response? Like whether they really like the product in the beginning, or how did they actually transit from the phase where they habituated to the design from the past 20 years, and right now you are asking them to use your product, and how did you actually come up with what do you say? How can you actually tell them that that's a very good design, something like that?
Well, I don't think you can tell anybody something's a very good design. It's a good design if they use it. Depending on our timing tomorrow, you're going to hear a bigger story about this, but I can summarize it here. That project started not because anybody said we want a lever-powered all-terrain wheelchair. It started from latent needs. It started from people saying, I cannot travel in a rural area on rough terrain with my normal wheelchair. I cannot use my hand-powered, crank-powered tricycle indoors because it's too big. I cannot go up steep hills with my tricycle because it's not geared correctly. And we heard about all these deficiencies in current products, and it made us realize, boy, there might be value in an all-terrain wheelchair that can be fast and efficient on rough terrains, but also small enough to use indoors. So the first step was understanding those latent needs, right? Then we went through a series of prototypes of ways that we expected you could go on rough terrains fast and efficiently and use it indoors, and we screwed up many times. We failed multiple times, but we failed early and often, and in context with the target users, so we understood why we failed. And the early failures was one, the ergonomics of the chair was bad and it was too heavy. Then in the next one, it was too unstable. Then in the next one, it didn't have, again, good enough ergonomics of the levers. And then finally, we got it to a point where people said, yes, this actually is superior to regular wheelchairs in many different conditions. So we went through like 4 or 5 major iterations in that project before we got to something viable. And I think even in that project, what we could have done a better job at was really understanding the economic models behind the market. Because we designed for a segment of the market where people wanted high quality, like what would be appropriate wheelchairs. Those are a vast minority in the global wheelchair market. The majority is the really low cost and relatively low quality wheelchairs that hospitals will buy, like government hospitals. And if we had met that price point, I think we would have had easier adoption. And we learned that the hard way. I hope I can show you more of this tomorrow. I'm going to try to do are you guys interested in hearing about that background? Like a deeper case study of that? Because I can do that. I do that in the class, so I was debating whether to do that tomorrow, but I'll try to do that. So that's a long-winded answer to your question. But I think the what to take away from it is that I think as a designer, you are rarely correct the first time around. And you're rarely, somebody made the comment at lunch, the Wright brothers got it right on the first try. As a consumer product, that airplane was a death trap. Like, it was incredibly dangerous. And actually, they ended up, so Orville, the other brother, ended up killing a guy. The first passenger of an airplane ever died because they crashed. And Orville dislocated his femur from his hip socket, and it stayed dislocated the rest of his life. Like, it was a really, really bad injury, or it broke in a weird way. But it affected him his whole life because it was a very unstable aircraft. Its center of drag was ahead of where the force of propulsion was applied. So it was kind of like an inverted pendulum. So Yes, it worked as an engineering proof of concept, but it didn't work as a product. Other questions?
So,
Yeah.
how can we use the desalination system for irrigation purpose? How can we scale it up?
Oh, that's a great question. So one of the challenges there is the value of potable water versus irrigation water. We nominally produce 10 cubic meters or 10,000 liters per day in our systems, which would be enough drinking water for about 3,000 people. That same amount of water is enough for about a half hectare of farmland, like a relatively very small farm. And these systems that we design, we're trying to hit a price point of around like $5,000 for that system. And that is a reasonable cost for a community of 3,000 people to bear. It's a difficult cost for a single farmer to bear. What we've done through a variety of innovations is we've been able to cut the cost of electrodialysis by about four or five times compared to what commercial systems are right now. And we're getting the water production cost down to a point where it's starting to make sense for agriculture, particularly if you're growing like high value crops like strawberries. So we currently have multiple proposals under review right now to do exactly that, to combine electrodialysis with agriculture for high value crops. And we're doing it by also combining it with our drip systems, drip emitter systems, which require half the pumping power as regular drip emitters. So we lower our power system cost. And drip irrigation versus flood irrigation cuts your water consumption in half. So you need to make less water, purified water. So all of that together, this is going back to doing the economic modeling. All of that together adds up to electrodialysis potentially getting to the point where it could be viable for agriculture. But the beachhead market, the first market that makes sense is potable water, drinking water, because we need to make so much less of it. And also, what helps is people come to us to get it. They bring their jerry cans to the water purifier and buy it from us and walk home. We don't need like a piping system, which also makes it cheaper. Other questions? Or do you want to head to lunch? Well, yeah, we can stop for lunch then, and then resume with some examples after. Cool, yeah. Oh, I have to say stop filming, please. Yes. Thanks.